Welcome to this afternoon's HPC session. Okay, so we already have the intro to HPC session on Tuesday, but that one is actually more of a generic and more interesting, I would say. And today's session is also, getting started, but we are actually going to focus on a specific HPC system, Frontera at TACC. And this session will be more, I should say, I wouldn't say boring, but less interesting because it's more practical, okay? But just bear with me and we will actually go through the basics so that you know how to use an HPC cluster. And then after this first part, we will go to the second part, which is actually getting a container, actually a CyberTraining container running on Frontera. And we are gonna look at one of the case that you already run in the morning, okay? So this is the outline for the first part. Pretty straightforward. Let's get started. Okay, so Frontera is the target system that we will be using for this session. So I already introduced Frontera on Tuesday. Actually, it's ranked number 19 right now, and it's actually the largest cluster. Well, I said here, dedicated to open science in the United States. But yeah, it's actually the largest in academia setting. Okay, so we have over 8,000 nodes. Each node has 20 has dual 28-core Cascade Lake Intel chips. Okay, you can read the specs, doesn't matter. Anyway, so the peak performance is 38 petaflops. I'm not sure if you pay attention for this morning's exercise when you run the CyberTraining cases. The CyberTraining also reports the floating point performance at the end, well, in its output actually, so you can actually compare the number. So 38 petaflop is actually a lot. Well, so Frontera, it's just like any cluster, right? It's a bunch of nodes interconnected, and this is what it looks like. So, so user is here, right? So we usually SSH through internet to one of the login nodes. Actually, on Frontera, there are 3 different login nodes, and there's some load balancing strategy, which will just assign you to one of the 3 login nodes. But you can also log into one specific nodes if you just give the name, login 1, 2, or 3. And the login nodes is then connected to the actual compute node, okay? Where the compute node is where you actually run the large-scale simulations or jobs or whatsoever. They are actually interconnected and with fast internet, well, InfiniBand actually. Okay, and then the compute node is then connected through network to the file systems, where on Frontera we have 3 different file systems. There's the home, work, and scratch. Okay, we'll get to what they are supposed to be later. Okay, but this is the overall architecture, which I already, mentioned actually on Tuesday. So to access Frontera, you will need a terminal, of course, that supports SSH, right? So you can do it from Windows terminal, your Mac terminal, some SSH application, external party, whatever. Also, there's the MFA requirement, which is some of you having issues right now. That's just unfortunate, but that's what security requires anyway. So if you log into Frontera through SSH, this is the type of command you need. Okay, so basically just do SSH your username at frontera.tac.utexas.edu. Okay, so here IanWang is actually my username. You will just replace that with your own name here. But then it will ask you for the password and the token code, which is a 6-digit code from your token app. Okay, and after that you will gain access to Frontera. Very straightforward. Okay. So once you are on Frontera, remember you are on the login node, but both the login node and the compute node share the same user environment. So it's just like any Linux system. right? I suppose you're all familiar with, right? It's just, you have a login shell. By default, it's actually bash, but you can request to change to different shells. You can actually look at the bash RC file on your home directory, which is, the bash profile that you can customize. If you're actually into Linux thing, you actually know what that is. If you don't, doesn't matter. Also, there's this environment variables path, LD library path. If you work on any Unix system, you know what they are. And there are all these Unix standard commands, cd, ls, man, whatsoever. Okay, it's just a regular Linux system. It's nothing different than any other Linux system that you've used before. But there's one thing that is different, which is a module system. On HPC system, there's a module system. On Frontera, we use this package called the LMod, which means a Lua-based module system, okay? So this is required to dynamically manage the user's environment, because on the HPC system cluster, we need to manage different versions of softwares like compilers, MPI versions, specific applications, those sort of things. And things can have conflicts, and users may not want to have every single package we provide from as a center to be available in the user environment. That's why we need a module system where user can just load the module they want, so that they can actually use the tools needed, like a specific version of compiler or MPI library. Okay. Next. So there's some basic commands you need to be aware of. So there's a module list, which lists the list the modules that's already loaded in your environment. There's a module avail, which shows the available modules can be loaded. Then there's the most important, which is the module load command. So you can do module load, give a package name. Here is MATLAB, so you load the MATLAB modules through that command. Of course, then you can do the opposite of that, which is the module unload. So you unload MATLAB with this command here. Okay, you can find more info about the module by doing module what is and the module name. Okay, one unique feature of LMod is the support of this module spider, which will actually search through the different module paths and show you all the available modules and the versions installed in the system. Okay, well, not really going to focus too much on this. Just need to be aware of this. The second part is good citizenship. Okay, why is that the second part? Because you are actually sharing Frontera with almost 2,000 other users all the time. So it's important to be a good citizen all the time when you are on the system, right? But what does that mean? It means when you're on a login node, you've got to remember what login node is used for. It's actually used to edit or manage files, transfer files, compile your code, submit jobs, or track your jobs. It's not actually designed for any computational workloads at all. So don't run anything on the login node. Don't just think, yeah, well, my code just ran for 10 minutes. It's probably fine. It's not fine, actually. Imagine if there are like 2,000 users all running some code that takes like 100% of the CPU for 10 minutes, the login node will just crash, right? So it's just not going to work. So always remember, don't run anything that's computationally intensive on the login node. That's very important. The second part is actually the file access. I touched that a little bit on the Tuesday's afternoon session. So remember, the file system is actually shared, right? So you need to avoid running IO-intensive jobs on any of the file system, okay? And this is important because us as seismologists usually do IO-intensive jobs because, our research is data-intensive. We handle large data sets. So we have large numbers of files, we have large files, and they are just in generally not good for the file system. So always remember, avoid open or close files repeatedly in your code, and avoid having too many small files in one single directory, because these will just break the metadata server of the shared file system, okay? And also, when you're transferring files, make sure you're not doing too many simultaneous recursive transfer, which also brings up the load to the metadata server. Okay, job access. So before submitting any large production jobs, always make sure to test your job at small scale so that you know it makes sense, right? And make sure that your job fits into the memory limits of the system constraint, and make sure it works fine. That's why you always want to test it at small scale. Then file system, okay? So I mentioned there are actually 3 different file systems. There's the home, there's a Word, there's a Scratch. They are different. They're different in terms of whether they're backed up. So home is backed up, and there's no purge policy, but it has the lowest quota, so only 25 gigs per user. Okay, so this is really for you to store anything that's important, right? You need to back it up, but they are not large. Then there's a work directory, which is you have 1 terabyte quota. This is also not purged, but it's also not backed up. And it doesn't actually handle intensive workloads. The work is actually used for you to have something that you want to share across the all the TACC HPC system. So basically, if you put something in the work on Frontera, you can actually access it from the work directory on a different system like Longstar 6. That's also a cluster attack, right? So it's actually shared, so you don't need to copy and transfer files over and over again, okay? And Scratch is actually the largest file system, and it doesn't have any quota restriction at all, and it's also not backed up. But it's actually subject to a 10-day purge policy. So files that's not active for 10 days, it will be deleted. Okay, so this is actually for very large files for production jobs, and it can handle relatively higher I/O workloads. Okay, so a little bit more about the work file system. Okay, so we also call this stockyard. Okay, so they are all defined as environment variable on the system. So basically, it's actually mounted on the work, random number of that's representative for your account, and then your username here. And then under that, there's the directory for different systems. So we have, well, this should be updated to Longstar 6, Stampede 2, and Frontera, okay? But the 1 terabyte quota is actually shared across all the system, okay? So you only have 1 terabyte in your work. So you can actually see the quota limits of your own account when you log into the system, but also you can bring that up through this TACC info command, which this is showing my own for my own account. You can see I'm actually using quite a lot of the home, work, and Scratch 1 directory, but that just show you how much you are using, whether you are actually approaching the limit. And if you actually hit the limit, you won't be able to run any jobs. You need to clean that up. So for heavy I/O jobs, okay, now always avoid doing that, right? So I mentioned on Tuesday already, try to reduce your I/O workloads, and if you can, always do I/O, use the local file system under /temp rather than even Scratch. Okay, so here are a few examples of what heavy I/O means, right? You can read that. I'm not going to do that, but you can actually see the file system is actually pretty vulnerable, and that's really because all these tasks actually is heavy on the metadata server. And if you recall my slide on Tuesday, we have a much less number of resource for the metadata server, so it's actually easy to break. But if you are just doing handling large file, in parallel, doing HDF5 files with parallel read or write, it's actually gonna give you really good bandwidth without any issues. There are some other I/O management tips that I'm not really going to focus on. You can read that. I tend to make these slides more, in great details, but I don't really need to go through all of them. I want it to serve as a user manual for you after the session when you're actually using the system. So you can go over it and learn more about the details, okay? So yeah, this is another basically example of how you can redirect your I/O workload to different directories. Not going to go into the details again. Okay. This is probably more important. So we always need to transfer files in and outside of the Frontera. So there are different ways you can do it. So you can do Linux command from your, so if you are using Mac or any Unix system, you just do scp or rsync. And that should serve the purpose. On Windows, there's the WinSCP application, which is free and pretty nice, easy to use. But if you need to handle very large data, like terabyte scale or even petabyte, well, you probably don't do petabyte. Terabyte scale, you can use this open source tool called Globus, which is pretty nice to do a very large file transfer, especially across different HPC systems or storage services that you have. You can read their user manual, figure out what that means. Okay, yeah, there are some other general tips. Again, I'm not gonna go into details. But yeah, one thing important is, rsync is probably preferred over SCP if you do large file transfer. Okay, well, so to compile your code on Frontera, we have some compilers available. So by default, when you log into the system, you actually already have the Intel 19.1.1 compiler loaded and available in your environment as one of the module. But also there's the IMPI library 1909, okay? But we have other versions of Intel and IMPI too. There's also the GCC module that you can load from, using module load command. So these compilers are the same and available from the login nodes and the compute nodes. Okay, so you can actually compile your code on the login node. There's also a lot of math libraries, but on Frontera, we prefer to use MKL, which has, BLAS, LAPACK, etc. built in and optimized for Intel's CPU. So here are some examples on how you may compile sequential code. Up is using the Intel compiler or using the GNU compiler, GCC. Yeah, well, if you work on C or Fortran before, you know what they mean. I'm not going to go into details, okay? So MPI stacks. So since you are using HPC system, you're probably going to use MPI, because otherwise you won't be able to use the distributed memory architecture, right? That's why Intel MPI is loaded by default, but we also have NVAPH2 available as the module installed on the system, okay? So one thing nice about this setup is that Intel MPI and NVAPH2 are both based on the MPICH specification. So they are actually ABI compatible. ABI means application binary interface. Basically, it means if you compile something with Intel MPI and then module load and switch to the NVAPH2, you can actually run the same binary with NVAPH2 MPI launcher, MPI run command, because the launcher can recognize the binary code that's compiled into your executable. Okay, so you don't need to always recompile your code if you're using one of the MPI library. Okay. So to compile your MPI code, you should use command like MPI-CC, MPI-CXX, MPI-F77, F90. Okay, so these are actually shell script that wraps around the underlying Intel or GNU compiler with some extra options to link in the MPI libraries, basically. So here are some examples on how you may compile your C or C++ Fortran code with the MPI compiler, either using Intel or Rapid2. Okay. So after we compile the code, we can actually get things started and running. Okay. To run the code, it's actually important, right? I mentioned, don't run anything on the login node, which means you need to run things on the compute node, and there are actually over 8,000 compute nodes available. That's why we need a job scheduler. So every single user request needs to be submitted as a job. You know, your computation needs to be submitted as a job, and the job will be handled by the job scheduler to assign it to the available nodes when possible. Okay, so the job scheduler available or being used on Frontera is called Slurm. It's actually the most widely used HPC job scheduler out there. Okay, so jobs need to be placed in a queue, or sometimes it's called partition. Yeah, again, below here is emphasizing, you know, don't run things on the login node. And here are some examples of what does that mean. Okay. So job scheduler is the one way to manage the resource. So it's also called a resource manager on HPC system. Okay. So Slurm is a particular workload management system. And what does that mean? It means it tries to schedule the job to maximize the utilization of the cluster, right? Well, you know what that means, right? So multiple users is submitting all different kinds of jobs of different size, meaning different numbers of nodes and the different durations, right? So some jobs may run for 10 minutes, some run for 2 hours, some run for 24 hours. So the scheduler needs to be able to coordinate that so that the system is actually not idling, right? So we are actually utilizing it at the maximum. Also, we want to minimize the wait time, right? Because users won't get happy if they just figure the job has been in the queue for days and just never get executed. And that's something the scheduler need to figure out, like whether this user's job has been waited for long enough that we need to prioritize it. Okay. So how does it work in the backend? This is actually quite more important to you as a user when you are using HPC system, because sometimes you may figure, yeah, I want to submit this job, but I can submit it at all different kinds of sizes. And sometimes I can submit multiple shorter running jobs or submit like one long running jobs. Which one is better? And to figure that out, you need to understand how the scheduler works in the backend. So imagine for the job scheduler, what it's actually seeing is a plot with 2 axes, right? So there's the x-axis, which is a time, meaning the duration of the individual job being submitted. And the y-axis is the number of nodes. So, you know, each node, each job will access a certain number of nodes. So these are the 2 information that the scheduler understands. Then the idea of scheduling is really just like playing Tetris, right? So you're trying to fill up all the space with, you know, as less hole as possible here. Let's see a few examples so you understand what that means. So supposedly we have one job coming in, and right now the system is just idling, so you just get started and executing. So it's actually running, okay? Now there's another job coming in, and it actually fits to the resources that's still idling. So it's actually going to get scheduled onto this upper number of nodes, and that job also gets running. So now the system is mostly busy, right? If there's another job comes in, Of course, it will not gonna, this is large enough, so it's not gonna fit into this tight space here. So it's just gonna be placed here, waiting in the queue, right? Straightforward. And if another one comes in, it's just gonna, queue it again here. So supposedly they will have the same start time, right? And if we have another job, where do you want to place it? Well, if you play Tetris well enough, yeah, you probably want to place that here instead of up there, right? Because here you actually minimizes the wait time of the user because it's going to get started right after this shorter running jobs. So this scheduling policy called first come, first serve, straightforward. Let's see a different example. So we have the current queue like this, okay? Now we have a new job that's like that, okay? So this job is interesting because it actually runs on all the nodes, and this actually has a particularly short wall time, which means it's probably going to take only like 10 minutes or so to finish, for example. How you might want to schedule it. Well, you may place it actually right after this long running jobs, but this may not be the best. So a better strategy is actually, place it in front of these two waiting jobs because, these two jobs is just going to wait for another 10 minutes or so. So it's not a big thing for them because, these jobs actually runs much longer than that. But then we actually minimize this wait time for this new job, right? So you actually get executed earlier. And then, because it actually uses all the nodes available on the system, we actually, increase the utilization of the system by doing that. So this is the policy called the shortest job first. Another one. This one's interesting. So say we have this long job. So this is pretty typical if you have like a long running sequential job, right? So it may just take one single node, but it run for like 24 hours or so. Now we have a job like this. Well, because this small long running job is already running, and there's no resources available for this job that actually takes the full number of nodes on the system. It will just have to be waiting here. There's no way to actually pull it ahead. Now, if we have another job that's about this size that comes in, what can we do? Well, instead of put it waiting after this large system job, we might just pull this ahead and place it here in this space so it actually runs immediately, right? And then if we have another job that actually can fit into this empty space here comes in, what shall we do? Well, again, we place that ahead of this job. Of course, because this job actually runs for longer than this already running job, it also means that we are actually pushing this job back a little bit. But because it just pushed back a little bit, it's not a big deal, and we still increase the utilization of the system. So that's preferred, right? So this type of scheduling is called backfilling. Okay. So we have all these three different strategies, and in the real world strategy, the CERN's scheduling system is actually utilizing all three of those, right? So it's actually using all these three different strategies to maximize the utilization and minimize the wait time of the user. Okay. So now we get to some basic commands for Slurm. Okay. So one thing that you probably more important is the sinfo command, which shows you the available partitions or queues, okay, on the system. So this -o option means specific formatting, because without -o, it's actually going to show every single details about the partition. So it's going to be a very large output. But here we see all available partitions on Frontera. So we have development queue, small queue, normal queue, large queue. Okay. So you may wonder, like, well, which queue should I use for a particular job I want to run? Well, we have another tool, but that's only specific to TACC, called queue limits. So if you do queue limits on Frontera, you actually get more useful information out of the available partitions or queues. So you see, for example, the normal queue has minimum node counts for 3, which means you need to submit a job that takes at least 3 nodes, or it's going to reject it. But you cannot go beyond 512 nodes. And the maximum wait time is actually 2 days here. And there's maximum nodes per user, max job per user, and max jobs to submit to the queue for the user. Okay. So you see the details, and you probably can figure out like which queue fits best for your need. Okay. Then we have the most common commands that we use daily basis on HPC system, which are sbatch, sq, and scancel. So sbatch is actually submitting a batch job, which is actually in the job script. I'm going to show you what the job script looks like. Okay. But if you do sbatch and give a job script, it's actually going to submit the job to Slurm, place it in the queue, and then you can use sq command with your username here to show the job that's currently queued under your name, of course, including the one that's already running. Well, this one is actually finishing, and the ones that's pending. That's what PD means. You can also do scancel with the job ID here to cancel a job in the queue. So whether it's already running or it's waiting in the queue, you can just do that to either terminate the job or remove that job from the queue. Okay, so yeah, Slurm script, right? So this is what a job script looks like. So basically it's a bash script, except that there is a bunch of sbatch primitives at the very beginning that gives Slurm the information about the job. So you can give the name of the job, the file for output and error, number of the task, so MPI task actually, and this capital N is the number of nodes. So we are requesting 4 compute nodes here, and the P is partition or queue. So we are submitting to the normal queue. T is time, 30 minutes job, and A is the allocation name. Okay. Then you can just treat it as a simple bash script. So here we are just doing a IB run my program. Well, you might wonder what IB run is. I'm going to show you later. So IB run is actually the TACC specific MPI run launcher. So it's equivalent to do MPI run basically. One other command you might want to use is called IDEF. It's also a TACC specific tool. But TACC, if you want to run an interactive job, which means you want to have like an active shell session on the compute node, you use IDEF. You do the same -A with your allocation name, P with the partition name. So here we are actually doing the interactive job in the development queue, which is usually what that's designed for, right? So you are doing some large development work that doesn't fit on the login node, so you want to use the development queue. Capital N1, so we are using 1 node for this interactive job, and we're going to run up to 16 MPI tasks here, and the time is 1 hour. And it's going to actually run and wait and automatically put your current shell onto the compute node that's been allocated by the scheduler. Okay, well, IB run. Well, tedious, but this is really a TACC-specific MPI job starter. It's calling the MPI exec Hydra of Intel MPI in the backend. For NVAPISH 2, it's actually doing the MPI run RSH. You actually set up the environment and network that's specific on this TACC system. Okay. So you can do some tricks to run multiple MPI jobs within the single batch script using IB run. Here's an example. So basically you can do IB run -N16. -O means actually the offset, okay? So you can actually run 3 different IB run commands together. So this one with the offset 0, this one with offset 16, this one with offset 32. Okay, so you have 3 16 no 16 you can do IB run -n 16 -o means actually the offset. Okay, so you can actually run 3 different IB run commands together. So this one with the offset 0, this one with offset 16, this one with offset 32. Okay, so you have 3 16 rank jobs, MPI jobs running. Okay, so basically that's 48. So basically you can actually use basically 48 cores on the system, right? But you're actually running 3 different programs. Anyway, that's tedious details. So with all that said, finally, we can get started on our hands-on session, containers tag on Frontera, okay? So now let's try to get onto the system. I'm gonna actually do it this way, okay? So for those of you that has the TACC account set up properly, please follow this instruction and do SSH onto Frontera, okay? Let's see. Is everybody following? Cool. Okay, well, so this session, what I'm gonna do is, so here I'm already logged in, okay? Here. You see my terminal here, do you?
Yes, we can see it. Thanks.
Cool. Thanks, Iris. Okay, so once you log in, you actually see, all this information, including this quota, whatever stuff. Then you get this prompt. Okay, so I'm actually gonna go to my track. Well, so first thing you can do is module list. So these are the modules that's loaded by default under your account, right? So in this session, we are gonna use the, I can't do copy and paste in this mode. Gosh, let me do that. Let's do this. Okay. So at least I can copy and paste. And hopefully you can see the slide. If you don't, go to our HPS website and download the PDF file so you can directly copy and paste. Okay. So basically you can do that, module load, TACC Apptainer, and do module list again. You see Apptainer is actually loaded already. Okay, so it's version 118 here. Okay. So to run this, let's go to our Scratch file system, right? Told you earlier, we use Scratch all the time. So now we can use go to Scratch with this shortcut CDS. So now we see I'm actually in my Scratch directory already. So you will actually see Scratch 1 with a different number and your own username here. Okay. Have I done with that? If so, we can then try to pull our CyberTraining container. Okay. We'll do that. And you will see it doesn't allow you to do it. Why? It explains it. Because you're on the login node. And login node is not supposed to run anything that's computationally intensive, which includes containers. So we actually blocked you by doing that from the login node. So we actually now want to actually use the request interactive session on the compute node. So we can use this idef command here. Okay. So if you follow that, do this. Oh, sorry. For me, because I have a 2-man project, I need to specify 1. I think for all of your accounts, you should have only one allocation, so it's actually not going to ask you for that. I don't think. Yeah, I think it's fine. Okay. Thumbs up if you are able to get onto the compute node, so that I know if everybody's following. Okay. I guess nobody can. I'm probably going too fast, but SSH, go to Frontera, do module load, TACC Apptainer, go to a scratch directory, and then you can do IDEF to get onto the development queue to grab a compute node. Okay, so you see I'm already on the compute node. This is the the name of the node, right? Let me head to the directory actually. You don't have to follow what I'm doing here. You can just do it in your own scratch, but I have too many files. I want to go into an empty directory. So now it's empty, okay? So what I'm gonna do is I just do Apptainer pool with the CyberTraining CyberTraining container from Docker. This is the same container that you run in the morning. So we can do that, and it's actually going to download the container and try to build it into a zip file. If you follow our Tuesday's container session, you know what that means, hopefully. If you don't, go look at that slide. Get you a review, I guess. Okay. It's actually creating the container file for Apptainer. How many of you can follow this instruction actually on Frontera? I still don't know like how many of you having account issues.
I just want to make you aware of there is a question in the in the Slack channel.
Oh yeah,
Lindsay got
okay.
something wrong with the interactive session.
Lindsay says he got this error. So basically, you need to specify a queue, which is this -p command or partition, right? So basically, if you do IDEF with a -p development, should be able to get over that problem. Oh, by the way, so if you copy and paste the command from the PDF, sometimes the dash is like the em dash, which is actually not recognized by the command. If you have some weird error, try to type the command in so that you don't have this em dash cost problems. I've run into that quite a few times. Yeah, so for those of you that's been added to the reservation, this IDEF command is actually going to ask you whether you want to use a reservation. Just hit Y, means yes. So it's actually going to put you on the reservation. So bar, you are saying you are planning to get allocation, so maybe you are not using our reservation. Make sure you hit yes, so that we have a reservation for 30 compute nodes. So you should be able to just get it immediately instead of waiting in the queue. Okay. Okay, so so you see here, my run is done, and you do ls, you see this training latest.sif file, which is created by this Apptainer pull command. Okay. So now, well, let's skip this part actually. So I have also like a generic MPI code where you can actually run. But due to the interest of time, let's finish the CyberTraining one. If we have like a time left, we can go back to the MPI one. But yeah, let's jump to this run containerized CyberTraining. Okay. So once you have the CyberTraining container in the directory, you can just do Apptainer run training latest.sif. Okay. So if you do that, it's actually gonna start up the Jupyter notebook. But we are not using the Jupyter notebook here actually, because I mean it's also not the right model. But the way we set up this container is that when it starts up the Jupyter notebook, it also copies the internal files from within the containers to outside to a current directory. So once you see this, you can just do Control-C on your keyboard and say yes to shut down the Jupyter server. And now you're back to your original prompt. Okay. Okay, and you're in your current directory. And if you do ls here, you see there's a CyberTraining directory being created by our Apptainer run command. Okay, so once we have that, we can go to the TPV13 directory. We are actually going to run that case, which is the first case you run in the morning, actually. So let's go into that directory. You see, these are the same files that you saw in the morning, the TPV13's input files, parameters, whatever. Okay. So now we are in this CyberTraining TPV13 directory. Okay, you see here. We can do Apptainer run again with the gmsh command. Okay, so this gmsh command is the one that you already run this morning, right? But now gmsh is definitely not available on Frontera, but it is available inside the container. So we can do Apptainer run, point to the zip file, which is 2 levels up because now we are inside the CyberTraining TPV13 here. And then we can do this command gmsh right after that. So it's actually running the gmsh from within the container. So we are actually doing the mashing here. Okay, well, so I'll just hit enter here. Okay, assume you are following. So it's pretty fast actually. So now you see the MSH file is created, which means the mashing part is done. Okay. Now let's do this pumgen command. So the pumgen code is actually an MPI code. That's why instead of just doing MPI run directly, we add this IB run in front of it, right? So but here, because this pumgen is actually pretty fast, we just run it with one MPI task, MPI rank, one MPI rank. So IB run -n1 and do this same pumgen thing. So this is actually running inside the container, okay, over that mesh file we just generated. So if we hit enter, you see it runs, blah, 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 successfully, which is great. Okay, hopefully you're following. I mean, I think there are quite a few that doesn't have access, so I'm just gonna go forward, keep moving forward anyway, so that people watching doesn't feel bored, I guess. But for those of you that's actually doing the hands-on session, let me know if you run into any questions, okay? Either unmute yourself to speak up, because I don't think we have that many, so it's probably okay to just unmute, or you can ask in the Slack channel. So after that, we can finally run CyberTraining, okay? What we can do here is we set the OMP number of threads to 28, so we're actually using 28 threads. Remember, on Frontera, we have a total of 56 cores spans across 2 sockets, right? So each socket has 28 cores. That's why we're actually using multi-threading over 28 cores. And then we are doing IB run with -n2. So we are actually launching one single MPI rank on each CPU socket. And each socket will run a task with 28 threads. So this actually gives us the optimal performance. Then same Apptainer run with the training latest zip file. And then we run CyberTraining and give the parameter. Okay, so the parameter is the one that's under this directory, TPE13. And CyberTraining is then running inside the container. Okay. So if we hit enter, you see actually it starts running. And it's done. Okay. So you can look at it, right? So CyberTraining reports the time it takes internally to finish the job. So you see that it takes only like less than 10 seconds. Okay. And CyberTraining also computes or calculates the floating point operations per second, which is the what we call the flop performance, right? So here in this task, we are getting a over 600 gigaflops of performance, okay? Which is pretty decent. Not sure if you still remember how it runs on your local machine. I think it took much longer than 10 seconds, and the performance definitely much less than 660 gigaflops. So yeah, so I think I have it written down. Yeah, so I tried it on my laptop, and it took 100 seconds actually. So it's 10 times slower on my laptop, running with 4 OpenMP threads, and the performance is 62 gigaflops per second. So it's actually roughly 10 times slower. Well, I should say Frontera is actually 10 times faster than my local laptop, which makes sense, right? One thing to note about is that this container is actually not built with the AVX512 vectorization, which I actually talked about, which is the optimal optimization lens for Frontera. So which means the performance can actually further improve if we have like a specifically optimized container for CyberTraining for Frontera. And that's something we are actually going to build in the future. And that's something the Scope project is actually pushing forward, which is the building the HPC optimized containers. With that said, I think we can conclude this session. And we have like 3 minutes for questions before I hand over to Bryant. Is Bryant here? Yes, he is. Good. Any questions? Let me see the Slack. My screen is a little bit messy when presenting. Bar said earlier, there's a remote file management tool. Okay, good to know. I didn't know that, but yeah, thanks for mentioning. Okay, so Felix asked, is it preferable to ask for many resources for a short time rather than a few resources for a long time? I would say yes, but it also depends, right, on the current status of the queue. So in general, yes, but But then you can always double check by using, the SQ command basically to see how, how busy the queue is and see whether there is a specific slot that you can fit your job in, right? So usually you can see there are, like, say 10 nodes idling, right? So if you can actually trim your job to 10 nodes, then you can actually grab that 10 nodes immediately. There's a lot of tricks that you can do by monitoring the current status of the queue. Because we saw this Tetris thing, right? Basically, you want to identify empty spaces or available resources on the cluster like this, and make sure your job fits into that space, if that makes sense. Okay. Oh yeah. Well, Sebastian already answered that question for me, but yeah, I think that that example, just some random numbers I gave there, doesn't mean, well, I wouldn't say this is something you want to do on Frontera, because it's not really fully utilizing the resources. I mean, there are only 56 cores, so yeah, Sebastian is right. Okay, well, if there's no any other questions, I'll just hand it over to Brian and Carl here. Okay. I'll just stop sharing. And thanks for attending the HPC session. Let me know if you have any questions.